Hello, Sheldon McDonald here. I'm doing a video today on exploring how we can make a mouse cursor in BASIC and then doing the same thing in assembly. So I'm going to start off with loading my disk utility. If you want to follow along with code that I've already submitted, you can go to my website www.smotion3d.net and you can click on the ASM tutorials and it'll show you the disk images that I'm currently working on and explaining in these videos. Okay, so I'm going to close that. So the same file that you'd be looking at, let's see, will look like this. So you'll have a basic program, an assembly program, and the assembly language program assembled. So first off, we're going to examine my basic version of this, and we'll talk about it for a little bit. Okay, so I'm starting off. I had identified the ASC key that I was going to use as a mouse pointer. So I'm starting off by clearing the screen. I have a little 4x loop here where I'm counting from 1 to 255, and I'm manually poking these ASC tables onto the graphics screen. And so in this loop it prints the whole table. Line number 45, I have J1 equals 0, J2 equals 0, PT equals 0. So I have some variables in here to remember what my values used to be, and the PT is going to be it's going to be the pointer of where the mouse was last at, so we can replace the cursor with the graphics that used to be there, so when we're moving it. Line 50, I said AR is -1. We're just going to use that as like an initialization, so it knows that our original graphic ASC code that was on the screen, that's where it's going to remember it. Okay, so we're just initializing it with a -1. Line 60, our mouse cursor is going to equal 95, MC. And here comes our loop starting at 70. JX equals int bracket joystick bracket 0 bracket divided by 2 bracket. So this will give us a joystick reading divided by 2, and it'll remove the decimal place. JY equals int bracket joystick bracket 1 bracket divided by 4 bracket. So what this will do is divide our y-axis from our joystick input, and we'll divide it by 4, so it'll give us a value between 1 and 16, since there's 16 lines on the default screen. And on the other one, it divides it by 2 because there's 32 character positions on the default screen. Okay, so line 80. If AR is -1, then this is where we're defining PT. So we're saying PT equals 1024 plus bracket bracket JR times 32 bracket plus JX bracket. So basically what we're doing there is we're taking, why is that JR? I'm going to be re-uploading that. JR. That's supposed to be a JY. Okay. So I'm going to put a Y in there. Okay, PT equals 1024 plus bracket bracket JY times 32 bracket plus JX. So we're taking the JY and timesing it by 32. because there's 32 lines per row. Or sorry, 32 characters per row. And then we're adding JX to that value to find the exact point on the screen. Then I'm saying AR equals peak PT. So we're taking the original graphic tile on the screen, and then we're poking our mouse cursor in that location. Okay, so this line only gets executed once, and that's probably why it was working undetected with the wrong variable in there. So let's go to line 90. This is the line that's going to trigger movement for the mouse cursor. So if JX does not equal J1 or JY does not equal J2, then poke the point back, which was our original graphic ASC code. And then we're going to say J1 equals JX, J2 equals JY. PT equals, we did this calculation again, and we take the new original, we take a new graphic tile, not graphic tile, then we take a new background character to preserve, and then we poke our mouse cursor on top of that. Line 95, go to 70, so that's infinite loop there. I'm going to save this. We'll save disk. Just put it on the desktop. Lesson 2, save. And I'm going to load VCC here. Okay, so now I'm going to load, I'm going to unload the disk image that I had. I'm going to insert disk 2, or lesson 2. So we can type dir to see our file in there. Load test ASC and run. So what this code did is it dumped our ASC table down, and it's also created a little mouse cursor that you can see that I'm moving around on the screen. And it's just following my mouse around. Okay? So now we're going to do this exact same thing in assembly. Okay? So we'll exit from this. And we'll take a look at the assembly version. Now the assembly version, I want to hand code it while we're talking, while I'm talking. That way it might be more easier to understand rather than having it pre-built. Okay, so I'm going to close that. I'm going to go to Program Editor, New. Yeah, let's clear that. So the first thing we want to do, we want to have our program originate somewhere in RAM. So actually I should probably have the caps key in so this will record better, so you can see it better. I'm going to originate at, we'll say 7,000 this time. And where is that in RAM? We can we type 7,000 in here. And it looks like we're at 28,672 in RAM. Okay. So program, I'm just going to write program start. Okay. Okay, so now we need a start, and at the end of our program we need an end to our start. Okay, so we'll start off by building that ASC table. So a way we can do that, we can load one of the index registers. So we can load X with 1024, a number 1024, number sign 1024. Okay, so I'm just going to comment, this is the screen start. Okay, and then we're going to clear B, CLR B, and then we're going to create a loop here. I'm going to call it LP1, and I'm going to say store B, comma x plus. So what that'll do is it'll store the B value at the x index place and advance the x index by one position. So that means we're effectively moving we're moving down on the screen we're moving on the memory for the screen. Okay, we're moving down. So what we'll write here. So now so we got store B. Now I want to increase B. Increase B, and what this is basically, what this does on its own, there's no operand that goes with it. This increases B by the value of 1. So this is the same as saying add 1. Okay. So now we need to compare the results. Let's compare B with the value 255. I'm going to go back just one. I'll say 254. Yeah, it doesn't matter. We'll say 255. Compare B number 255. Okay. So we're checking to see if we're saying does B equal 255. Okay. And if it does, that's where the branch commands come in. Branches are used for executing if certain conditions on the bit flags are what it's looking for. So in this one's case, B and E. No, we're going to use B low. So actually. BLS, I think. So branch lower or same. And truthfully, we don't really want to increase B past 255. So we're actually going to use B low. So if it actually equals 255, it won't actually loop again. If it did, it would reset the B index to 0, or B register to 0. So I'm going to BLO LP1. Okay, so this will loop until that condition above is true. Okay. All right, so this first little bit is going to do it's going to actually print the that ASC table. And this is actually a lot smaller than the basic version of this. Let's put wait for key press. Actually, let's not even do that. We'll just put a RTS at the end. RTS. And that'll be a return to basic. Okay. So then I'm going to bring this up. Let's do a test here and see how this looks. Okay. Oops, I'm going to cancel that. So I want to actually save it to a disk image. So we'll save it. And we're going to assemble it. Okay. And we'll save disk. I'm going to save that on my desktop here. And now we'll load VCC. And I should still have that disk loaded from looking at it last time. Okay, so I can go load M, new PRG. I'm gonna clear. Actually, I'm just gonna execute. Okay, so that did the exact same thing as the other program, except it's just lacking the mouse. Okay, cursor. Okay, so that was actually extremely fast too. We were witnessing it running pretty slow for the basic one. You could actually see each character being drawn, but assembly is so much faster. The second I hit enter, it's done. You can't beat that speed. If you want to get into any serious gaming or whatever, or programming, then you'll definitely wanna jump over to assembly language for sure. Um, okay, so that's that portion of it. Um, now we're gonna have to build a now we got to build a routine that um, looks at the joystick. Okay. Okay. Continuing on. I had to cut that video there a little bit. I'm trying to fit these videos into a half hour or less. So I'm going to load that disk image that I had. So what I was just going over, let's have a quick look at it. So basically what we're going to do now is we're going to build, I need to build a joystick routine, and then I need to build a mouse cursor routine. Okay, so there'll be two subroutines that we're going to do. I've already, however, done these, so I'm just going to go over it and explain the code just to shorten this up. So we'll go to the program editor. Oh, actually, let's take that one. So this is the one that I've submitted onto the web page, so you could follow along. And so this is what I've done. The program originates at 7,000, which is actually 28,672 in RAM. I built a start label, and I have an end to my start at the very end of my code here, an end to my start. Okay. So at the very start, I'm loading X with the number 1024. I'm loading the X register with the number 1024. I'm clearing B to equal 0. I created a little loop here, just like I explained earlier. So all that this is doing is putting all the ASC codes onto the screen. And now this part here is new from here. Key check. So the first thing we're going to do in the loop, we're going to jump to subroutine JSR to joy CHK. All right. So that will get our joystick values. And then this is basically, consider this our main loop right here. Then I'm going to JSR jump to subroutine mouse. Okay, subroutine update mouse. Then I'm going to jump to subroutine the ROM address A000, and that's that ROM routine I was talking about that checks for a key press and returns the result to A. I'm going to compare A to 0 if it's BEQ, branch equal, to key check, which means no key was pressed. So this would be like a continuous loop until I press a key on the screen, and then at the end it'll RTS return to basic. So let's look at our mouse cursor. Actually, before we look at the mouse cursor, let's do it in order. Let's look at joy CHK. That's the first subroutine that it's looking at. So I've made it nice and easy to find it. I put these all these multiplication signs in, the asterisks, to kind of highlight where my subroutines are. Okay, so joy CHK. So in order to get joystick pot values, we need to play around with some hardware addresses. So I'm kind of, some of this I'm still learning, but I can explain some of it to you, and feel free to just copy this code completely and use it in your own projects. What I'm basically doing here, I'll try to explain what I can. So I'm loading FF23, and I'm ORing A8, and I'm EORing A8. So what that's doing is it's forcing a value on and then shutting it off. And then I'm restoring that value back at FF23. And if I'm correct, it has something to do with the 6-bit sound enable line. And so as far as I understand, I'm shutting it off there. Somebody can correct me if they know what I'm really doing. LDA, number sign, $ 3D. Store A at $FF03. So basically I'm setting up those hardware addresses, so we're looking at the joystick voltage lines, okay? And there's two of them, so there's one at the FF03 and the other one I'm setting is at, I'm LDAing number $ 3C and I'm storing that at FF01. So this is what's needed to set up for looking at the left-right access of one of the controller ports. We'll start off by clearing B. So I've got a label here called joy left. We're going to store B at FF20, which is the address that'll compare. This is the address that'll compare the value with what's at FF00. Okay, so we're storing 0 there to begin with because we need to test to see where that voltage level's at. So now we're loading FF00, which is loading the actual voltage value. BPL joy LF. So branch positive, I believe. So that means if we've branch positive, that means I've hit a number that's gone past the voltage that is currently showing, okay? So then we're already there. So maybe in this instance, if it jumped there on the first loop, we'd probably have our joystick value at 0, and we put voltage to it and we're already over, so it's jumping out. So basically that's what this loop is doing. We keep increasing the voltage until we're higher than the voltage, okay? And then it'll fall through to the next label, which we will be playing around with that number, okay? Add number $04. If we write 04 here in the hex, it shows us that we're emitting the first 2 bits. The first 2 bits are different, have a different function at that address. The only bits that can measure voltage, the DAC, is the high 6 bits. Okay, so we're just increasing the number from the top 6 bits on. Okay, so when we're comparing B to the number $FC, that's basically saying that we're looking at just the top 6 bits. Okay. Branch equal to joy LF. So if we've actually hit an equal value where the comparator has come out as the same result, then we're exiting. Okay, and it's the same thing that if we've overshot it, then we're also exiting. Okay. Branch always to joy left. This creates a loop until it finds the right voltage to pass through. That we finally measured the right value. Okay. Okay. So now that we're finished, we have a voltage level. What we need to do is get that value to fit on the screen. But before we do that, we need to make it into a proper value because it's still an 8-bit number. Okay, so what we can do with this is we can logically shift right B, and what this does is it drops a 0. Okay, and I'm doing this twice, logically shift right B, so it's dropping another 0. and it actually ends up putting zeros on the other side of this number. So we get a true value once we logically shift right twice, okay? Now I'm storing that value at $015A because that's the same place that BASIC is storing it, so I might as well store it at the same place. Now we're going to set up for the y-axis. I'm going to LDA the number $34 and store that at FFO1. So now we're ready to look at the other pot and play around with the voltage on that one. Okay, so joy right. Really this should have been more like joy up, but for some reason I labeled it as joy right. I'm going to rename it here and upload it to joy up. We're going to call this joy up. Okay. Okay. So store B. So we're storing a cleared value there again. We're doing the exact same thing as we did up here. Okay. So I'm going to just change this to joy up. And instead of this right finished, it's more like up finished. Okay. And so I'm going to put a U here as well. Okay, so joy up, and yeah, so that's fixed. So I got to do the same thing with this value. I need to logically shift right B twice, and then I can store that one at $015B, and then RTS will return from my subroutine. Okay, so now we're back up here. We've finished the joystick. We've gotten the joystick values. Now we're going to jump to subroutine mouse, which will update our mouse cursor. So let's have a look. Mouse starts right here, the mouse cursor. So what I'm doing is loading point. So you can see that I made some variables in here. Let's scroll down. So I have some variables here. I got OR value. I got the CR val. I got point. I got joy X, and I got joy Y. Those are my variables. You'll see that point is a double value, and CR val is also, no, that one's just a single. And that's actually my cursor ASC code that I'm going to be storing. And original val is where it's going to be saving the original ASC code that was on the screen. So let's go back up there. Mouse. So I'm loading the point, comparing D to 0. If it's 0, then it hasn't been initialized yet. So branch equal to init CR. Okay, so that means if that's a 0, we haven't initialized it yet. We haven't actually taken the original graphic ASC code yet that was on the screen, and we want to preserve it, so we need to take it first. So we would jump to init CR. So if we scroll down, I have init CR here where we're loading A, which is the joystick value. We're storing it at joy X. We're loading A with 15A, which is I think it's the up-down axis. B was going across X, and A was going up-down. Okay. I'm going to store that at joy Y. Then I'm loading X, which is the index with 1024. That's the screen start. I'm loading A joy Y, or joy X, sorry. I'm logically shifting that value right A. So what am I doing there? Because my joystick value has a range of 0 to 63, I want to cut that number in half for the x-axis. So I'm logically shifting right A. That'll effectively cut that number right in half. And then I want to add that to my x index. So I'm typing load effective address x, LEAX, and then I have A comma X. So that'll add A to the X index. Okay. LDA joy Y. So I'm loading my joystick Y value in. Now this one I need to cut down even more. because I need it to fit into a 16. I need to fit into 0 to 15 value, okay? So I'm going to logically shift right A twice with that value. Then I'm going to load B with the number 32, and I want to multiply that. And then I can store D temporarily at point. Then I can transfer X to D. So I'm transferring the X value where the X index is at D. And then I'm adding that point in that I temporarily stored. And then I can store D point, because now I've added those numbers together and stored it in the same place. I can transfer that back to X now. So TFR D to X. I can load A X, and I can save the original value now, store A original value, and then I can load our cursor value and store that at X and return from subroutine. So that would have actually exited, because I said RTS there, it actually exits from the entire mouse subroutine. It would be the same as this one here, except it would have come back out at our main loop. Okay, it would have jumped back to this line here where it says JSR and we go to the ROM routine. The reason why I did that is because it didn't need to go back into the main code. It can just return from subroutine. You can have multiple exit points from a subroutine. Okay. Okay, so we've initialized it. So the next time it goes in there, it'll go to, so we're doing a compare to see if joy X is equal to the original saved value. If it's not equal, it'll go to update, which is here. And then we'll check the Y axis value, compare it to Y, and if it's not equal, go to update. And the only difference with the update code is that I need to load the original value first and load point and then store it. Truthfully, after this, check this out. I can actually just delete all this code. I didn't actually need this now that I think about it. I could have deleted this, and I could have just said, I could have just let it fall through to the init CR because I've already replaced the original value. How cool is that? So that makes the code just a little bit shorter actually. And that's it. It checks for a mouse pointer, or sorry, no. It checks for the ROM key, like if we're pressing a key on the keyboard, and if it does, it'll return to basic, and if not, it'll just keep infinitely looping. So when we load this now into VCC, load M test and execute. So now it's actually in assembly, okay? This is the exact same thing that we did in BASIC, but now it's in assembly. And it is very fast too. You can't beat this speed. Like I said, assembly, you're going to want to do everything in assembly. It is absolutely worth doing the jump and taking the leap. And that's kind of why I'm doing this video series is I think a lot of people like me was like that only know how to program BASIC kind of get scared at looking at it and think, oh dang, that looks really difficult to do stuff. But it's not really. You just have to think of a different way how to do those things. And you've got 3 things to do it, or 6 things to do it with. You have the A register, the B register, the D register, the X, Y, and U indexes. And you have to do everything with those 6 things. But it absolutely can be done, obviously, because the basic ROMs were built using that structure. Obviously, they're using the S stack as well and the PC, but We don't need to use those because we're just users. We're just the programmers that program on top of it. All right. I hope this could be. I hope some of it can be learned from. If not, I don't know. Drop me a line if there's something I could do better. Again, I'm a learner myself, so the next video I'm going to be doing will be converting 2 bytes to a human readable number on the screen. And you would think that, oh, that should be, pretty dang easy. I mean, on BASIC we're just saying print print a number, blah blah blah, right? And it prints it. That is absolutely not the case for assembly. We actually have to convert our bytes into human readable form before we put it to the screen. And maybe that's a portion that might sound scary too for beginners, but I'm going to walk you through it, and we're going to do that one on the next video. All right, thanks for watching.